quite glad to be able to mention now, because I'm used to working in this system rather than degrees. So we can from now on move to this system. This system is called radians. So in a circle there are 360 degrees. And you think about it, that is a really it's something we probably grew up understanding. But why did we pick that number? We could have picked any number. We could have said there was 1 degree in a circle, and then we could split it up accordingly if we wanted. We could have said there were 100 degrees in a circle. We could have said there were 1,000 degrees in a circle. The reason why 360 was the number we chose with is because it's a very composite number, as in lots of numbers divide into that. If you think about 1, 2, 3, 4, 5, and 6, they all equally divide into this number, so it's quite easy to split it up into smaller parts in an intuitive manner. But once we move to a more mathematically formal setting, the effective 360 is just kind of like, why did we pick this? Now I'm going to introduce something that might seem a bit weird at first, but just go with it. Technically, I believe that we should have had an algebraic letter just called tau, which would stand for a whole circle. It would make lots of things easier. But instead, we say that there's 2 pi. There's 2 pi radians in a circle. So these are another way to measure how far along the circle you are, right? So 360 degrees or 2 pi radians. So radians and degrees, right? They're just different units of measurement. It's like centimeters and inches, So we're gonna be switching or migrating our brains over to radians from now on. Now, why did we choose 2 pi? Man, I don't really have an answer to that. I might write it in the description later. I just kind of, unfortunately accepted it and moved on. It seemed kind of weird. But I know some people define pi to be the first root of sine, actually. So if we sketch the graph of sine, instead of having degrees, now we're going to have radians. So this would be 2 pi, and this would be pi. And then 90 degrees is half again, so that would be pi over 2. And in between pi and 2 pi, that's 3 pi over 2. So that corresponds to 270 degrees. That's the first sort of thing to get used to. I noticed that the first 0 of sine is pi. And if we sketch cos, we're going to get different things here. Yeah, so this is pi over 2, this point here, 90 degrees, pi over here, 3 pi over 2 here, and then 2 pi corresponding to this point. So there it all is. Those are radians for you. So 2 pi radians is a full circle, 360 degrees. Pi radians is 180. It's a straight line. And there it is. Kind of weird, right? Kind of this strange, almost sounds like nonsense concept. Now let's think a little bit about formulas for areas of a circle and what they look like when we introduce radians. So this is one good thing the radians actually have to offer, right? So we have this big circle here, and if we're working in degrees, first of all, what's the area of a circle? You should know it's pi r squared, right? That's the radius. So if we were to work out a segment, a fraction of the circle, in degrees, we would usually write this, so theta over 360, because that's the portion of the circle we're considering, right? Like, imagine if it was 60 degrees, then this would work out to be a sixth of the circle, and everything would add up. But instead of writing 360, what if we wrote 2 pi and we worked with radians? Then the area of the circle actually becomes r squared over 2 times theta. Right? It's a little bit of a nicer formula. Now if we also consider the circumference, so we know the circumference is 2 pi r usually, and if we were working in degrees it would be 2 pi r times the fraction of the circle we're in. But of course we're not working in degrees, we're working in radians, so I can times by 2 pi, and that's a really nice formula. Now this stuff cancels out, so that's just r theta, and that's one use of them, right? So if you were asked to calculate, you know, the circumference or the perimeter of a circular sector, it's going to be quite easy. So imagine we had it just given to us in radians here. I don't know, let's say this is pi over 6. And over time you'll learn that pi over 6 corresponds to 30 degrees. But if this is pi over 6 and let's say the radius is 4 centimeters, what is the perimeter of this shape that I've drawn? Well, it's just going to be 4 plus 4 plus whatever this guy is. So that's r theta. So that's 4 times pi over 6, isn't it? So that's 4 pi over 6. 4 pi over 6 corresponds to 2/3 pi. And then plus 8. So that's my answer. And the area is just going to be r squared over 2 times theta. So it's going to be r squared, and 16 over 2 is 8 times theta. So pi over 6 is going to be like, yeah, going to be like 4 pi over 3 for the area. So those formulas are useful for working out the area and so on. And then you just need to think about what we did with graphs and sketch them using radians instead of degrees. And then you need to think about solving trigonometric equations using radians. So if you're using a calculator, there's always a way to change from degrees to radians these days. You just go into the settings and fiddle about with it. Whatever your calculator is, just Google, how do I change from da da da, and you'll be able to work it out. If we do a small example of an equation, let's say, I don't know, sine of theta is equal to, say, root 3 over 2. So you might remember the answer in degrees is going to be 60 degrees. But 60 degrees corresponds to pi over 3. So that's one of the answers, and then by reflection symmetry, you'll get this out to be the other. Because, you know, you can just take it away from 180. There's symmetry around the 90 point. But 90 is not pi over 2. So it's sort of a shift in perspective of the world now we're undergoing here. But yeah, it's not that bad. They're not really that difficult to deal with. You're just kind of measuring things on a different scale now, but everything we did up to this point is still the same.